This morning today, and I am indeed very happy to participate on this Ozone Day to share with you some of my thoughts about Ozone Day as well as the current pressing problem of climate change phenomenon. In fact, when the climate change phenomenon came into the center stage of the world, Ozone Day preceded it, actually. The World Ozone Day is actually a process that was inaugurated after what is called the Montreal Agreement, Montreal Convention, or what have you. And since the inauguration of Ozone Day until today, every year, Ozone Day is celebrated on the 16th of September. And if you look back on the Ozone Day slogans, well, one slogan was ozone today and oxygen tomorrow. Another is ozone now or ozone later, oxygen later. Deal today with the ozone for a better tomorrow. Earth without ozone is a house without roof. Save ozone and save earth. And ozone layer is actually a ultraviolet radiation blocker, and ozone is actually something similar to what is called a sunscreen. And if you look at the chemistry or the composition of the atmosphere or gases in the atmosphere, lower atmosphere especially, you look at this pie diagram, and 78% of the atmosphere is shared by nitrogen, and 21% is oxygen, and remainder of 1% is by other gases. And the other gases are trace amounts of carbon dioxide. Note the word trace. Trace amounts of carbon dioxide, methane or CH4, water vapor, neon, oxides of nitrogen, and so on. Now look at this. Most people would know or would not know what is the structure of the atmosphere. Well, the atmosphere is divided into sub-elements. Immediately above the Earth's surface, the zone is called the troposphere. That is where we all live. It is only 10 to 15 kilometers above the ground surface. Then there is what is called a tropopause, and followed by a stratosphere. And of course, beyond that, we have even though this graphics subdivides it, you have the ionosphere, ionopause, and then space. So we are actually focused today morning when we talk about the ozone on the stratosphere, because it is the home of ozone is in the stratosphere, in the upper troposphere and in the stratosphere. And then, for example, it was discovered way back in 1975, actually. In 1975, we did not have what is called IPCC, Intergovernmental Panel on Climate Change and so on and so forth. No. It was actually discovered in 1985 by a team of scientists who worked for the British government, and they reported some kind of a ozone hole. In other words, depletion of ozone above the South Pole. And in fact, Mr. Farman, Gardiner, Shanklin of the British Antarctic Survey in May 16 reported in Nature the levels of O3 over South Pole. It is actually a success story of climate activism. And this is actually an image. It's an animated image of how ozone changed. And if you think of ozone, even though ozone is thick, if you bring down to because it resides in the low pressure area, as you go up in the sky, up in the atmosphere, the pressure is decreasing. And if you take the ozone from ozone layer down to the earth's surface, it will be compressed even at the available, whatever pressure you and I face. Under that pressure, ozone will reduce itself to just 3 centimeters, 3 millimeters, not even centimeters. So look at this. That is what the importance of ozone is. One, it is a UV blocker. Well, most people who have studied a higher secondary or pre-degree or physics subsidiary in the college would know what is the UV radiation, what it is, how harmful it is. Well, UV radiation is blocked by trioxygen. I use the word trioxygen because O3 or ozone is 3 oxygen atoms together. And these 3 oxygen atoms jointly create the ozone layer. And what is the harming thing on the ozone layer? Just chlorine. If you can send up chlorine to the stratospheric heights, then naturally chlorine will destroy the ozone. Chlorine will, what chlorine does is it will dissociate ozone into oxygen and one oxygen molecule and one atom of oxygen. Anyway, since the 70s, all these people who are working on this ozone phenomenon and the thinning of ozone in the southern hemisphere, they were recommending, they were arguing, they were through resolutions, they were asking the various nations and governments and leaders of the government to ban what is called CFCs, chlorofluorocarbon, and chlorofluorocarbon. You have a chlorine atom, you have a fluorine atom, you have a carbon atom. So this CFC, one advantage is the CFC is very light compared to our ordinary air. The density is very low. So if you open up a can of CFC, very easily it will rise up in the atmosphere all the way to the ozone layer and beyond. But of course, before it reaches the realm of the so-called beyond, what happens is the chlorine will get released from the CFC. And where do you find the CFC? Most of us in Kerala are familiar with what is called the sprays, different types of spray. Well, what is called deodorant sprays. And the aerosol sprays, as they are not only deodorant, aerosols. Sprays are actually the driving force in the little can. On top of it, there will be a thumb button. And if you press that button, whatever contained in it will come out, and along with that CFC will also come. And also in all the air conditioners we have CFCs. Well, of course, in 1978, the US EPA, Environmental Protection Agency, made a decision to ban production of CFCs since 1978. That is the advantage. Even then, even in 1978, we were not talking about climate change and sea level rise. Think about the antiquity of the concept of ozone and the harms ozone can do to the earth. Earthlings, human beings settled on the earth, all the living plants and animals in the earth. In 1987, 46 nations signed what is called the Montreal Agreement or Protocol, and later all the member nations of the United Nations ratified it. India is also a signatory of this. Well, like I said, the oxygen molecule is actually by splitting of oxygen molecule. How ozone forms? That is the question. Ozone forms on its own. Ozone forms on its own in the ozone sphere. What it is what it does is a oxygen atom, O2, oxygen molecule is split into two, and they will join the available oxygen molecule to create a O3. That is what creates O3. And obviously, when we open up a can of CFC, what will happen is it will go up, rise up. We will have the fresh smelling and deodorizing spray stuck to our garments, but the driving force the CFC will rise up. Or also, when you have an air conditioner, if there is a leakage of the refrigerant in the air conditioner, or if there is a leakage of the refrigerant in your household refrigerator, there is release of CFC. Of course, once it was banned in 1978 by EPA and later on by other countries in the world, the quantity of release of CFC to the atmosphere has steeply come down, and actually it has finally saved the ozone layer, and actually it has repaired the ozone hole that was recognized over the south pole of the earth. Okay, O3 is a fragile shield. Yeah, why is this fragile? Because anything that we do on the ground here will affect, a layer of ozone that occurs somewhere between 15 kilometers above to 50 kilometers above the ground. And even though the Montreal Protocol was accepted by the member nations of the United Nations, and all the countries are not involved in release or manufacture of ozone. All the industrialized countries, like for example US, European Union, including India, whoever was making the air conditioning machine or the refrigerators and related stuff, they were manufacturing CFC, and buying time, saying to the United Nations that within the next 5 years or next 10 years, we will cut down the CFC release or use. And CFC is very important in the sense, even after the ban by US EPA, CFC is actually used in aeroplanes, in the cabin of the aeroplanes, as well as in the cabin of the submarine. Any submarine vehicle, including a submarine or a submarine vehicle in the sense, for science, for scientific work, people are diving down in submersibles. And all the navies all over the world, they have at least one or two or many submarines. And inside the submarine, once they are below water, you need the CFC to maintain the livable, oxygenated environment. Another interesting thing is, like you see in this slide, in 1995, Nobel Prize in Chemistry was awarded to Mario Molina, Sherwood Rowland, and Paul Crutzen for the chemicals harming O3 layer, or O3. In other words, they have identified the harming chemicals that harm the O3 layer, and this was accepted by the scientific community, and as a recognition of this discovery, in 1995, Nobel Prize in Chemistry went to this team. Okay? Well, CFC is non-toxic and non-flammable. Look at the advantage. They are non-toxic and non-flammable. That is the beauty of the CFC. And the O3, Ozone Day highlighting Montreal Protocol, actually led to several changes. For example, these days, currently, the CFC is not used as a refrigerant. For example, Whirlpool, one of the giant industries in the world in the area of air conditioning, refrigeration, and household equipments like washing machines and cooking ranges, they wanted to open up a factory in China. China was just expanding. China was trying to show its might. And obviously, being a big industry in this refrigeration area, Whirlpool wanted to open up a manufacturing facility in China. Not in a place, but several places. You know what the Chinese told? Because in the background of Montreal Protocol, they have to invent some kind of a substitute for CFC. Unless that is done, there will not be any permission for the Whirlpool company to open up the shop. That is what the Chinese government told the Whirlpool company. And then finally what had happened was, this has the need to cut down on the production of CFC had affected even car air conditioning. Not only, all these new generation refrigerators, new generation air conditioners, and even car air conditioners do not make use of CFC. Instead, if you have access, you check through a workshop where air conditioners are repaired, and you will then discover what is called R3. It is a trade name for the new refrigerant used across the world, not only in India, all over the world, in the manufacturing sector. Well, one good thing about this kind of Montreal Protocol was, each decade, 1 to 3% of the harm done to the ozone layer was repaired. This is actually a clear indication of the need, the foresight, the necessity, and the importance of a international protocol like the Montreal Protocol. Now, that is what the status of CFC is now. And in other words, CFC's production all over the world is on the decline. And by regulation, instead of CFC, what is called in the trade circle, R3. That is what is used as a refrigerant everywhere, wherever refrigeration is needed. In the air conditioners, in the automobiles, as well as in the room air conditioning. Now, from here, what I want to do is I want to go to what is called AR-6, because AR-6, in other words, Assessment Report 6, is a very important new document that was released to the international community in the month of August this year. That's just a month ago, because we are only in September now. And what is this AR-6, Assessment Report 6? Assessment Report 6 is actually a report submitted by to Intergovernmental Panel on Climate Change, IPCC. Most of you would remember or may not remember, a person by name Mr. Pachuri, Dr. Pachuri or Professor Pachuri, who was the director of theory in New Delhi. He was holding the chair of Intergovernmental Panel for Climate Change, or IPCC. And the IPCC had been, once it was formed, were publishing, assessment reports. Now it is the Assessment Report 6 over a period of 7 to 9 years. Once in 7 to 9 years, they will publish a report. And this report on AR-6, Assessment Report 6, is the most crucial, critical, and with the far-reaching consequences if the governments in the various parts of the world, globally, if the governments do not contain the carbon dioxide emission, the world is headed toward a very disastrous consequence. In fact, the Assessment Report 6 has 3 parts. It is for the science. There is a part for the scientific community. There is another part for the governments and policy makers, and yet another part for general public. And what is the report here? The report says we have to until and unless the global governments across the world, all the member countries of the United Nations, if they do not decide upon cutting down what is called the carbon emission or carbon dioxide emission by burning fossil fuels, the danger of carbon accumulation, carbon dioxide accumulation in the atmosphere, lower atmosphere or the troposphere, that will reach a level at which there will be a runaway climate change. And the most important thing is they have given a date or a timeline which is 2030, 9 years from now. This is the problem. Unless and until some drastic measures are undertaken, are implemented, designed and implemented, and all over the world, not only the most important emitters of carbon dioxide are, one is United States, two is China, three is European Union, and though India is fourth, India is actually several orders of magnitude, Indian emission is several orders of magnitude lower than the first three countries or groups of countries. So we are emitting, India is definitely emitting, India has a share, only difference is the most developed countries like the United States and China and the European Union, their share of emission of carbon dioxide is several times that of India. That is the problem, or that is the India's advantage, I would say. In other words, the number one emitters, like first America, then China and the European Union, they are the ones who have to take up the lead in cutting down carbon dioxide emission. So, and what is the consequence in India? In the report, as they wrote in the report, India has a lot of problems due to this carbon dioxide buildup, even though India's share is low compared to several orders times lower than that of the the first three nations. In other words, European Union, the group of countries in the European Union, then China, and topping the list by United States. So what we face, let us not worry, we have to worry about the global situation, but let us focus more on what would happen, what is in the waiting for India. Rise in declining rainfall. Well, in Trivandrum today, this morning, we had a very heavy rainfall for about at least 1 hour. Today is September 16. And unfortunately, IMD will never say 70 years ago on September 16, in the morning, there was a rainfall or no rainfall. This is the problem. Because we are poor record keepers, or even if there is a record, the authorities who hold the record, they always think that this is not for public consumption. So we have a rise in declining rainfall, rise in the declining of rainfall, and deficit monsoon in central and eastern India. Since 1950, records show the AR-6 says there's a rise in frequent heavy downpours but decreasing normal rainfall since the 50s. Over the period of 70 years, we had a rise in frequent heavy downpour. For example, a week ago, in the weekend, Delhi Palam airport runway was flooded and the airport was shut down. Keep in mind one thing, Delhi sits in the semi-arid climate. Then the previous weekend, what we saw was what is called flood in Gujarat. Otherwise, most of the Gujarat state is a semi-arid area. Anyway, coming to aerosol loading and reducing atmosphere temperature. Aerosol is natural aerosol is there. Anthropogenic aerosol is there. For example, soot emerging from the tailpipe of all the automobiles, trucks and buses. That is actually small particles of carbon, unburned carbon, that will be rising up in the atmosphere and adding to the aerosol. And then another interesting thing is, especially in northern India, what happens is, in the so-called BPL or poor people who are in the villages, they always rely on dry biomass as a source of fire for cooking food, temperature or heat for cooking food. And what will also happen is that process of burning biomass for cooking in the kitchen, that also releases a lot of aerosols, particulate matter. And we have a very interesting name in this context, Mr. Veerabhadran Ramanathan, who is now a professor in one of the universities in California and shares adjunct professorship in 6 different US universities. Interestingly, this gentleman was called by the current reigning Pope, when Mr. Pope wanted to have a picture of climate change, reported to Mr. Pope by the experts in the field of climate change. So Veerabhadra Ramanathan is actually a BTech from Annamalai University in 1970. Then he did a PhD in Indian Institute of Science, and later on emigrated to New York University. Happened to work with James Hansen, one of the climate scientists. You know what James Hansen wanted Veerabhadra Ramanathan to do was go back to India and look up what is the quanta of soot, SOOT, or it is also what are the unburned carbon by burning biomass. What is the volume of soot that is released by this Indian people from the villages who cook food in the open fire? Ramanathan went back with this data, and the data says, it adds to the aerosol. What is the advantage? If you have aerosol in the atmosphere, it leads to cooling. Why it cools? Why the ground cools? Because the incoming radiation from the sun is retransmitted towards the sun, toward that space. So it cools. It gives a cooler feeling in the ground. And once the monsoon, when the rainy season starts in the northern India, all the aerosolic particles, including the carbon so-called soot, that will settle on the soil, and in the process, a huge quantity will also settle over the Himalayan glaciers. And disadvantage is, in the Himalayan glaciers, when the carbon particles sit on the surface, during the daytime, when sun shines, this black surface, the soot will attract heat and transmit to the low underlying ice. What is the problem then? The ice will start melting excessively, and that will cause wasting of the glacier. That will lead to wasting of the glacier, which is actually one of the impacts of climate change. All the glaciers there is a study that told the Hindu Kush area, the glaciers and ice sheets in the Hindu Kush mountains, that is northwestern part of India. It will affect India, Pakistan, and Nepal and China, insofar as water resources of these countries are concerned. So another interesting thing is, it is going to affect what happens to the land use in India. When land cover change, Indian land cover is actually, natural land cover is your vegetation, your water bodies, your soils, and your rock. And of course, we do remove rock and minerals to a large extent, because that is an indispensable source of material that will add to the economy, development of the infrastructure, and so on. But then if you do soil, naturally it is going to affect the soil, the yield per hectare yield. If the soil is lost, per hectare yield of the crop is also coming down. And also there is urbanization. One estimate says by 2070, 70% of the Indian population will be living in the urban areas. What is the advantage of going to the urban area? The advantage is, you find jobs easily. By definition, an urban tract is a place where 75% of the population will be living or depending on non-farm related jobs. That is the urban area. A place, a agglomeration of people where 75% of the male members, 75% of the males work in the non-farm sector. That is an urban area. It's actually a definition by Census of India. Now, for example, I said that land cover change will add to what is called a local heating up of the, for example, it is called a heat island. That's it. Every town is a heat island. In other words, the nighttime temperature is not low, instead it is rising. The records that were available to assessment report 6, that shows even in India, our temperature at night time was going up. That is quite bad. See, daytime temperature, let it go up. We can manage by, drinking water or taking shelter under a shade of a tree. But if the nighttime temperature goes, what we lose is moisture held in the lower layers of soil and the rock. If at all there is rock is holding moisture. Now, for example, Kolkata, temperature was up by 2.6 degrees during the period 1950 to 2018. Well, this is a very important, this is a threat. What is called, several of the coastal cities will face threat of sea level rise, says NASA. And in fact, NASA has published what is called an interactive map. You can download the interactive map by NASA. You can put the cursor at roughly around the Kochi, and you can click and find out what is the rate of sea level going up in the coming years, in the future, in Kochi. The map is available, not only for Kochi, for the entire world. Another interesting thing is, this map is published on September 12, 2021. That is 4 days ago. And what it says is, it is the carbon dioxide concentration in the Mauna Loa Observatory in Hawaiian Islands. Mauna Loa Observatory is on one of the Hawaiian Islands, which is something like 3,000 meters above sea level. And this has been working right from 1950s. This curve is called the Keeling curve. And look at this curve. This is zigzag and going up. And currently, on this particular day, carbon dioxide content was 413.05 ppm. And since keeping of the record in 1960, this is the rise. Definitely a roughly linear rise. And in the 1960s, the atmospheric carbon dioxide content was very low, as low as 310 part per million. This is the living proof. This is the living proof of carbon dioxide buildup. And unless the carbon dioxide level is not brought back to what it was in the pre-industrial days, that is like, for example, 1850 to 1900. That is the pre-industrial day time frame. If the carbon dioxide content is brought down in such a way that our temperature, which is more than 1.5 degrees Celsius to 2 degrees Celsius, higher than what it was in the pre-industrial days, that will do all kinds of harm. And that is the exact reason that all the nations will have to work toward bringing down not only the addition of carbon dioxide, but release of carbon dioxide, either by what is called an engineering solution, or a carbon sequestration by natural processes, or by revegetation, or by geoengineering. Well, these are some of the examples of in this picture. What you find is, you see a hammer-like thing with a chain connected to it. That is an oil well. In other words, what that picture indicates is, it is indicating the use of pumping of crude oil. The crude oil consumption is a very important area of contribution toward what is called carbon dioxide release. And then the pictures above, you see large pieces of blocks of rock blocking a highway, a road. And this is actually a rock slide. And rock slide is triggered by heavy rainfall. On the right side, you see a picture with ice slabs. Ice slabs. See, today's Madhurumi says, there is a small report. In Greenland, there was rain reported last week. Greenland is a place where you get only snowfall. When Greenland enjoys rainfall, what it means is the air temperature is sufficiently higher so that there is no snowfall. It is more than 4 degrees Celsius. The temperature of air is more than 4 degrees Celsius over Greenland. How? Greenland is, close to the North Pole in the Arctic Circle. And why is there? You have a temperature like 4 degrees Celsius plus. And that is because of global warming. The entire northern hemisphere is enjoying the global warming. Most people are living in the countries and nations in the northern hemisphere. Keep that in mind. Well, consequences are many. You have forest fires, you have rising sea levels, and of course, picture on the left hand the top shows, emission of carbon dioxide or smoke. Well, take for example, in Indian situation, our electricity production is
carbon fixation or carbon assimilation. That is synthesis of carbohydrates from carbon dioxide. Carbon dioxide in the carbohydrates synthesis carbon fixation and carbon assimilation. Right.
What do you want me to do? Did you want me to do something? Hello?
No, sir, you can continue.
Yeah, but please ask that gentlewoman to keep quiet. I will finish off in another 10 minutes, okay? Then we can talk about whatever I said or whatever they have in mind. Thank you.
Okay, sir. Okay, sir.
Well, of course, take a look at these pictures. These are the consequences of climate change. Uncontrolled carbon dioxide emission or carbon emission. Well, look at the pictures very carefully. The first picture on top left is an Indian from some town in India, northwestern India. This is a flood. On the right side also, top row, you have flood. You look at the color of the water. And then on the left bottom, people are walking with bottles. Even the dress tells us they are somewhere in North India. Why do you walk with a bottle of water? To cool yourself. Unbearable temperature. And today again, I think in the Madhurumi or so I read, there was a popular news which said the temperature can go as high as 50 degrees Celsius during daytime. Is it a bearable temperature? Certainly not. People will become incapacitated because they will not be able to work outdoors. We have had examples of asking the private enterprise not to let the employees work between 11 and 3 in the recent years. And then you take a look at this coconut tree and the water body there. Water body is the ocean. And why the coconut leaves are pointed in a certain direction? Because of the storm, because of the storminess, because of the wind. Well, these are other pictures to demonstrate what will happen due to the climate change. We have, desertification, as it is called, desertification. For example, in 1932 or 33, there was a dust bowl situation in the central United States. I should use the word Midwestern United States. In other words, very valuable topsoil was blown away by stormy winds. A similar situation is predicted now. California is fighting what is called wildfires. And they also have a situation where water is very scarce. Whereas in New York City, because of the storm called Ida, even subways are flooded. Even 4 Malayalis died in that flood. They were driving in a car. The car was stalled by the floodwaters and they could not get out. Many people got out. Many people were rescued. But unfortunately, 4 people in 4 different cars died. And then lightning. There is a picture of the lightning. What happens? In India, every year at least 1,000 people die of lightning. That is the statistics. Well, what is it? Time is running out. Absolutely no doubt. What I am saying is, it is now time for the younger people in India to form climate activist groups, social activist groups, and spread the word about climate change and how harmful it is going to be. Keep in mind one thing, any change in the climate will affect the poor people first. They will be the casualties, not the rich ones. This is a problem all over the world. So it is for the masses to line up against the climate change and they have to force the government to implement policies. For example, one slogan is don't burn anything, never burn anything. So these changes are going to be irreversible. Now I am coming down to what happens to Kerala. We have done a work several in 1990, 92. Okay, take a look at India. This is the India and the sea around India. Look at the west coast of India. Look at the east coast of India. The sea floor is there. You can see the sea floor. There is no water. This is the structure of the sea floor of India. You can see the Himalayas, the Tibetan Plateau, the Pakistanis that are Western India, etc. This is actually a map that was published in 1972 by two geologists in the Columbia University, New York. Not yesterday it was published. It was published in 1972 under a sponsorship of National Geographic Society. National Geographic Society. This is not a very old map. This is a very recent map. Actually, it was published again by not an Indian source. What it tells us is the red color. Watch the red color. All these red colored areas are areas bound to be flooded by rising sea level and also the loss of life. In other words, you can see Kolkata and part of Bangladesh. You can see part of Orissa. You can see Visakhapatnam. You can see Chennai with the red color. And you can also see Kochi. Then you can see Mumbai. And even in Mumbai, I refer to what is called NASA's interactive map, cartogram. And if you went to Mumbai, with a cursor there in the interactive map, you will get a picture of how fast Bombay will be threatened. Bombay will go underwater. Why not? 2 days ago, maybe I read in Times of India, a minister in Maharashtra government talking about sea level rise and consequences to this area called Mumbai. I'm not saying all of Mumbai will go, but so-called, the Mumbai island, that will be under threat. This is a map of Kerala. It shows the physiography. It shows actually the coastal plain of India, of the state of Kerala. Coastal land or coastal plain is the part of the landscape of Kerala where elevation from absolute sea level, mean sea level is 7.5 meter or less. You will notice that there are some gaps in this map along the coastal land. Those maps are areas, for example, Kannur. Kannur is high standing area. Kovalam, Thrivikramji is standing high. Or Varkala is standing high. So these are not the places that will be affected by this, what is called a sea level rise. But what is the so-called low coastal land, that is where the threat is, including Kochi, including part of Thrivikramji. Yeah, because the Kovalam is south of Thrivikramji. And wherever why not, Kuttanad will be at very high risk. The coal Karinilam of Thrissur. From the Kuttanad to, it is a wetland. It's a Ramsar site. The entire Ramsar site and adjacent areas will be threatened by sea level rise. And what happens? What is the consequence? Consequence will be more of sea water entering into the Vembanadu Kayal. Vembanadu Kayal water level will go up. And think, the rest is to your own imagination and your own logical thinking. But it is going to go up. So this is some of the numbers, because Kerala has 92 kilometers, cumulatively 92 kilometers of high coastal land. The remainder is the low coastal land. And here I have given some numbers regarding, what the number of the loss due to sea level rise. Now, this is the morphology of our Kerala coast. Top one will be example of Kovalam. Top two, second image will be, this cartoon will be representative of a cliffed shoreline. And the third figure is representative of, let us say, Kollam or south of Kollam. And the fourth one will be the water body, which is marked as L, is Vembanadu Kayal, and then you have toward west, when you west is toward right here in the right side. Anyway, so this is the general makeup of Kerala coastal land, and definitely the last one will be under most threat, and also the second one, third one from the top. Sea level is going up by 1.1 millimeter per year. It can go up faster also. That unless and until we cut down on the carbon dioxide emission. Well, this picture is very informative as well as caution. It has to be looked at with caution. Caution in the sense, this is something which is actually telling us what is the future of Kuttanad will be. This image, the red color, is actually the last flood in 2018 flood. The red color is the flooded area due to the 2018 flood. This is part of a paper that was published. Now, I did not publish, it was published in Science. And also look at the bottom right-hand picture, image. That is actually for a different scenario. Again, the red color is the a region, a tract which has a tendency to get flooded. Now, this is the road, beautiful road it was. The picture is, camera is looking toward the north. This is the right of way or the road through which people cruise to the Trivandrum domestic airport terminal. Now you have to walk all the way. There is no way to, or else you have to take a circuitous route. And a diaphragm wall is contemplated and under construction, but unfortunately, even diaphragm wall will fail. Absolutely no doubt. Because most of the road is gone. And this is in Trivandrum. For the last 4 years, it is like this only. Sand is gone. No new sand is coming in. And of course, the commoner says that it is because of the Adani port that this road has underwent erosion. Not only this road, look at the size of the buildings. These are all private buildings. And the sensible people will retract. There is no other solution. And erosion management plan is to retract and relocate to the higher ground to the east. That is the only solution for this problem. Instead of fighting, you yield to the forces of nature. And another interesting thing is, you have to spread the word, communicate. Tell all the people that this is the situation. Unfortunately, keep in mind one thing, every year in the school level, all over India, 261 million kids are going to school every year. In the school age children, that number is 261 million. After higher secondary, the number is only 26 million who go to college, who go to university, who go to professional colleges. So, roughly the 200 million, they drop out. And unless we teach them right from the middle school to the elementary school, from the elementary to the middle and the high school, these people will be climate illiterate, climate change consequence illiterate, which is very bad for the nation, which is very bad in the long run for themselves, those people concerned. So this is what I have to say on this day. We have solved more or less our ozone problem. Nobody is talking about the ozone hole now. And like I said, 1 to 3% over a decade. In other words, over 10 years, 1 to 3% of the hole is removed. hole is refilled with ozone because of the actions, policies, and technologies implemented. Or that is substituting chlorofluorocarbon with a new concoction called R3, which is a trade name. All the cars and everywhere it is used. But like I said, CFC is still used in the submarines for supplying air as well as in the aeroplanes. So with this, this is my message. We have to do our role, our community's role, our society's role, our government's role. We have to force the government to cut down, to make them cut down what is called emission, harming emissions. And it is present day, the harming emission on this day itself is not ozone or O3, instead it is carbon dioxide emission. Thank you very much.